Hello 8th graders, I found a new tool on my iPad. Now, 10.6 covers volume. Now I know you've done volume before, this is not a new concept, but we're going to take that concept and put it with new concepts that we are learning this year. So the first thing, you know volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will fit on the inside of something. So if we look up here at the top, we will see that Cavaliers Principle is a new concept. Cavaliers Principle says that if two three-dimensional figures have the same height and have the same cross-sectional area at every level, they have the same volume. So let's look at this. It says up here that a right prism and an oblique prism with the same base, which you can see here, we have two triangular prisms, and height, they would have the same volume. Now these at the bottom, volume of a prism, you should already know all of them actually, but the first one you might not. So the volume of a prism is going to be V equals base area times height. I want to make note once again that that is not a base. That's base area. That's the area of whatever shape of the base we're talking about. And the height is, remember, plane, the perpendicular segment or the perpendicular line that goes from both planes of the bases. Volume of a rectangular prism, length times width times height, and the volume of a cube is a side cubed. So if we're finding the volume of a prism, in this case you can see that we have the volume of a right rectangular. That's not rectangular. So we're skipping part A and B because it's pretty easy. So we're going to find the volume of each prism. Now in this problem we have a pentagonal regular prism, a right regular pentagonal prism. We have a base edge length of 5 meters and a height of 7 meters. We just want to find the volume and it seems pretty easy. However, there's a lot of things we have to take from other chapters to get this correct. So we know the volume is base area times the height. So the base area though is the area of the pentagon. Well, wait a minute. The area of the pentagon, if you remember, is 1/2 the apothem times the perimeter. So we're going to plug in 1/2 of the apothem times the perimeter times the height, which we know is 7. We don't know the apothem. Now we do know the perimeter, so I'm going to leave the apothem blank. The perimeter is going to be 5 times 5, which is 25, and the height's still 7. So what are we going to do? Well, I'm going to redraw the triangle here, but we're going to have 2.5. This is going to be 36, and we need to find the apothem. Well, how do we do it? Well, we have an angle measure, the opposite side, and the adjacent side. So we're going to actually have to do tangent of 36 degrees equals 2.5 opposite divided by adjacent. That would give me the value of the apothem as 2.5 divided by tangent of 36 degrees. Now if I do that, let's see, 2.5 divided by tangent of 36. Well, if I did that, I'd probably get an estimation value. So I'm actually going to take that right there, that, and I'm going to plug it right in. So I'm going to put 2.5 divided by tangent of 36. If I figure that out, 1/2 times 2.5 divided by tangent 36 times 25 times 7, that gives me a value of approximately 301.1 cubic meters. So approximately 301 1/10 cubic meters is the volume of this right rectangular pentagonal prism. All right, in example number 2, we're going to do a marine biology application. Oh, hold on one second. I forgot to put myself in the corner. The aquarium over here, as you can see, oh, let me move myself here. Ooh, there we go. The aquarium over here is a rectangular prism. So really easy, we're just going to find the volume, length times width times height, and it says that is going to be 57,600. and that's cubic feet. But it then says the density of water is about 8 1/3 or 8.33 pounds per gallon. Estimate the weight of water in pounds. Well, the first thing you have to know is the conversion factor. So if you don't know it, you're going to have to look online. So you're going to have to figure out, well, how many cubic feet are in a gallon? Well, if you did figure that out, 1 gallon is approximately, that's really bad here. Let's try that again. 1 gallon is approximately 0.134 cubic feet. So if 1 gallon is approximately 0.134 cubic feet, what are you going to do? You're going to divide. So you're going to take 57,600 cubic feet. Now, if you haven't done this, you should have done this last year, but I'm going to real quickly show you how you can convert. You know that 1 gallon is approximately 0.134 cubic feet. So the feet cubed cancel. So this is going to give you approximately 1 gallon and 57,600 divided by that would give us approximately 429,851 gallons. But we know then up here, if we look at the top, look up here, it's 8.33 pounds per gallon. So you're going to have to multiply this times 8.33 pounds per gallon. The label of gallons cancel. And so you're going to be left with approximately 3,580,659 pounds. So the weight of the water in pounds is about 3.5 million pounds. So now let's look at Cavaliers Principle again. Cavaliers Principle says that I can have 2 stacks. Like for example, this is 2 stacks of CDs. If you have 2 stacks and each stack of CDs is the same number of CDs, then these 2 cylinders have the same volume. It doesn't matter. For example, this base here and this base here are the same. The height here and the height here are the same. It doesn't matter that it's like tilted a little bit. The heights are still the same. Now you've done cylinders before, so I'm just going to make note. The formula for volume of the cylinder is pi r squared h. So in example 3, we're going to find the volume of the cylinder with a base area of 36 pi squared inches and a height equal to twice the radius. Well, here's the good news. Volume equals pi r squared h. Easy, it's the volume of a cylinder. This right here is your base area. So they're telling you the base area is 36 pi. All we need is the height. So what is it? What is the height? We know the height is equal to twice the radius. Well, what's the radius? Well, if it's pi r squared represents 36. That means the radius would be 6. And so twice the radius would be 12. And we multiply, and 12 multiplied by 36, 432 pi cubic inches. And rounded to the nearest tenth would give me 1,357 2/10 cubic inches. Now in example 4, I gave you all of the work. And they actually figured out the original dimensions and the effect if you multiplied everything by a half. If you multiply the radius by a half and the height by a half. But remember, we're cubing this. So remember, you're taking a half, which is the radius squared, so you're really squaring that, and you're taking a half of the height. So really, this is 1/4 times a half, which gives you 1/8. Because 1/2 squared times 1/2, this is the same thing as taking 1/2 cubed, since you are taking the volume of something. You're cubing something. So you could go through the work, or you would know 1/2 cubed would multiply the volume here by 1/8 if you multiplied everything by a half. There is no new vocabulary for this section other than to know what Cavaliers Principle states.